finally did just have the courage to say, okay, that's enough. Like, yeah, I appreciate that when you guys call each other out on stuff. So today we're doing 621 because we spent all of the time yesterday working on the mastery. It was not technically assigned. That's why I crossed it out and wrote it on today's. This, we still got to figure out when stuff is going to be due. I don't really care that much when stuff is due as long as we turn stuff in. So we can talk about that probably at the end of class because my guess is we'll actually get through class somewhat efficiently today. At least that's my hope. Make sure that you solve entire problems. This is still a reminder because as we do multiple reflections or rotations or translations, there are multiple steps to problems. Some of you are using highlighters to color code and say this was this part, that was that part, and that's a brilliant strategy. Go ahead. She broke it. That's what I thought at first. It was like, I told her to go ahead and now she broke it. Max, the purple rhinoceroses run through the plains of Arizona. I know. I know. Don't worry. They pay me the big bucks to say random things like that.
Oh, that's for it's recording. How much do they pay you, man?
Like $5. 5 whole doll hairs. Alright, so yeah, doll hairs. Save up enough doll hairs, you can get yourself a doll. On your paper, it says from class, it kind of says A, but the hole punch had another thing to say about that. Go ahead and plot those points. However, you don't have axes on here yet, right? So the first thing we need to do when we're going to create any plotted points is create axes. So again, I will say, if you don't have 621, you are not looking at this paper with us, raise your hand and I will deliver it. Yes? What do you mean? Well, how did you graph them if there are no axes? There have to be, even if your axes were invisible, there have to be axes in order to graph them. Those of you saying, what are axes? It's the proper way to say the plural of axis. Because we do not say axes. That's just weird. We say axes, like axes, except not the sharp weapons that we use to, take down our tree friends. Axes. So, especially with what the copier has to say about when I make copies, we're starting to get into, and there's really nothing I can do unless I waste a bunch of ink darkening up the entire copy, which I don't want to do. You can kind of see it goes like every other, right? Like I don't know why, but it sort of goes every other, but not consistently. I don't know. I'm sorry. It doesn't look great. It kind of, well, thanks. I appreciate you saying that. So, what I'm giving Connor a hard time about was if he just went ahead and said this is 0, 0, he has determined that this is the x-axis and this is the y-axis, right? He went at, even if they're invisible, and then my bet is that he counted by ones just as default. But guys, some of us are continuing to accidentally do this backwards with your x and your y. Every coordinate point that has just 2 values is in XY order. If it has 3 values, it's X, Y, Z, and it involves a 3-dimensional graph. So we're not there yet. So 2, 1 is 2 right, 1 up. Please double check with your team that you all have created the same shape as each other while I pass out your pages. Looking after you have all those points graphed and you agree with each other. Just give me, dude. I'm trying to do too many things at once. Just give the paper to its rightful owner. Then, to each of those values, every x and every y, double them. And plot that shape. Man, this. Ooh, did we say 4 quadrant? No, I did not say 4 quadrant. So if you have run out of space, that's okay, but like you got to work with your partners then to talk about what is happening. If we made this our x-axis and this our y-axis, we would be safe to do what it's asking us to do. I'm not going to say you need to get out graph paper and do it over again, but if you want to, you can. If you're going to sit there and like, complain about having nothing to do it again. I mean, you could extend your graph, I guess. Except you have to extend it way far out. I do now have pencils. I restocked. Wow, we're missing people today.
It's so much fun.
Hey, it's not just Jay. Actually, you know what? Jake, Japanese fly fishing, Jake. What? Because it's his initials, JF. But it's a code word for him to come back and tell me. Although he probably will watch the video because he already emailed telling us that he's sick and he wants to know what to do. He's doing the right thing when you're sick of like reaching out to your teachers. Because y'all think we're aware of every student who's absent, and we definitely aren't. Until you guys come back and say like, yo, I was sick. What did I miss?
Also, I'm gonna, on Thursday, I'm gonna only be here for 15 minutes.
Okay, well, then we'll enjoy the 15 minutes that we have with you. So, 2-1, 3-1, 5-5. Not 5-1. Crap. 1, 2, 3, 4, 5. This is the danger with working in pen. And 2-5. Maybe at the end of class. Yeah, exactly. That's how I get you hooked. And then maybe you'll do the thing and then maybe we'll finish. So, what sort of shape is this that we start with? Ooh, it is a trapezoid because we have 2 sides that are parallel. So then, if we double every x and y, my red would turn into 4-2. It was my reminder to go get pencils. And hey, look, I went and got pencils. 3-1 doubles to 6-2. Yeah, if you made a 4 quadrant, your graph's not big enough, but that's okay. Then we have 10-10 and 4-10. 10-10, like 10-10. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 4-10. Stop it. Ah, darn. 4-10. Yeah, good. 1, 2, 3. Yeah, so then connects. Now, here's the cool part. You're like, yeah, wait, cool part in math? Yeah, right. Take your ruler. Don't have a ruler? Get one. Take your ruler. Line up this dilated point with the original point, and it should line up back to the origin. Then do it again. Not always, but all points will relate back to Yeah, not always. So somebody already said the origin. You're right. In this case, they're all going back to 0, 0, but it will not always relate back to 0, 0. We're going to figure out what that our 0, 0 is serving as here. But now this starts to kind of look like three-dimensional perspective, which is a great place for me to put in a plug, a shameless plug at that, in second semester. So quarter 3 and quarter 4, so January to like May. Phoenix does a thing called Friday Creative Option. The class I will be teaching during Friday Creative Option is the connectivity between mathematics and art. So we will take time researching and exploring and playing with and creating art utilizing mathematics. Here's the problem. You can only pick one FCO, and every FCO class is sweet. So like Mr. Smith is doing one involving the NPR podcasting challenge. Yeah. Mrs. Goldring is doing one involving like old school artistic crafty stuff. Like I think hers is string art. Like there's all sorts of sweet Friday creative options. Mine will be math art. And if you think this is cool, I'm going to blow your brain when you come to math art. But you got to sign up for it. So that we'll talk about at Forum on Friday. And then you guys will sign up next week. So this, anyone know what this is called in mathematics when you take a shape and make it bigger or make it smaller? Your eye doctor does this, Spencer. The technical name is actually what your eye doctor does, which is why they'll put those glasses on you before you leave, Nevin. Not quite. If your eye doctor scales your eye, that's a little... Scaling is normally when you like take something like you scale a fish. Dilating. The technical name for what we're doing here is dilation. When your eye doctor says they're going to dilate your pupils, now it could go either way. Sorry, if we got stories about the eye doctor we have to share, I can wait. Dilation can go either way, but it is changing of size by multiplying every characteristic by the same thing. So, we can enlarge or reduce. If we enlarge, which I think a couple of you were going to tell me like to enlarge or to scale. And scaling also is the same word that kind of works with this. But if we enlarge, our scale factor we know will be greater than 1. If we reduce, and this is where we technically cannot say divide, we are multiplying, so our scale factor there would be less than 1 to reduce. So here, the scale factor that we used was 2. We doubled. Got 2 times as big. This, the point that your dilated through your original connects back to, this is what we call our center of dilation. I mean, here it is the origin, but it will not always be. Sometimes your center of dilation is right in the middle of the shape. Like you're literally dilating out from the center of the shape. Sometimes you're dilating from one of the corners of the shape. Hey guys, when I go to grade your 621 homework, I'm going to expect some random things to be written around this, right? So like the random stuff I wrote here, that's what I would expect to see. Even if you accidentally made a 4-quadrant graph, this is like, I'm going to expect to see information about dilation written over here. Questions on enlarging, using a multiplication by bigger than 1, or to reduce, we don't technically say we divide, we say we multiply by a value less than 1. We're using math symbols to make taking notes easier. Spencer. Yeah, so some people like to say dilation and act like there's another A there, and actually technically I need to go back and double check. Yeah, there's no extra A. So it's multiplication, but just dilation. I know. I know. I know. There. So I don't really care how you say it. Just know there is no A here. It's dilation, right? There's no A in between I and L. Oh, hey, look, it's down here too. So, I got a question for you to talk about before you do it. So, and actually, yeah, we got enough time to actually do this. So, let's real quick figure out where these points are so that we can grab our graph paper and do this. So, guys, this is kind of annoying because they don't have us on an actual grid. Good thing my smartboard lets me cheat. Because it'll fix my straight line. So that's -6 if I don't pull it off of there. This would be 8. So we're going to write these down with each other in a second. Oh, that's nice. It goes through the y-axis. Helps me out there.
What part is this from?
So I didn't have enough space on your paper to put this question on there, so we're going to do this one on graph paper. So we will 4-quadrant graph this one.
Yay.
But hold on, you want to see how big to make your 4-quadrant graph first. This is why I'm not telling you to set this up yet. Not telling you to set this up yet. You're going to be sad if you do. Let's write down where these points are at. Those of you that are up getting graph paper, come on. It's December. You're fine. Get graph paper. It's December. You know that's the weird graph paper with no hole punches, right? This is, okay, because that's slightly bigger. It doesn't fit in your binder as nice. This is kind of the more general, regular.
We've used so much graph paper. I have none.
So guys, some of us are still goofing this up, and I've seen it on your practice work, and I don't count your practice work wrong, but some of us are goofing up X and Y. The left and right comes first. So for this point, we were at -6 on the X. What's the Y? 8. For this point, we were at +6, -4. And for this point, we're at -2, -4. Now here's the thing. I'm going to ask you to graph this, but also I'm going to ask you to graph when we multiply the coordinates by -2. So I want you to first talk to your team. What's going to happen when we multiply each piece of every coordinate by -2? And then do it on your paper, because you should talk first to determine how big your graph needs to be. Right? How big does your graph need to be? I mean, I would first talk with your team, not much team there, about how, like, what will the coordinates of your dilated shape be, right? When we're multiplying, we're dilating. Ooh. So, like, our top point, -12, 16 is what it will become. Oh, -2. Ah, last time we just did +2. So wait,
That's what threw me off.
this becomes positive 12, negative 16?
Yes, sir.
Yes, sir. Yes.
So I think this is, please don't call me sir, that's weird. Oh, for the record, I don't even care if you call me mister. I was talking with a student the other day. You can just call me Hudson for all I care. I think we're at the point in the school year where, like, I don't need you to put a mister on my name to respect me. I think we've got some mutual respect already figured out. I don't care if you just call me Hudson. If you disrespect me, I'm going to call you out on that. But mister or not, you could disrespect me even with calling me Mr. Hudson. So wait, negative, I don't think this is going to do the same as the thing we just did in the start, right? So then double check that you did negative 2, so negative 12, positive 8?
Yes. Oh. I'm used to it.
Okay, sir, yes, sir is just kind of fun. Sir, yes, sir, I get. But like, four.
You have to say yes, sir, yes, ma'am to everything. And so I'm used to it, so I do it all the time with teachers, and then I feel bad.
So wait, the bottom left point isn't going to stay in the bottom left?
Nope.
No. It's going to be on the top right.
Interesting.
It's like flip.
So make it on your paper. I would put that probably near the middle of your paper, right? So you got plenty of space to go. By the way, I think we all have talked about this, but the 5-star graph paper has squares of 2 different sizes. When you realize that you're going to be using bigger numbers, it's sometimes smart to flip over to the smaller squares because it makes your life easier. Then you don't necessarily have to change your scale. We can just like use the smaller squares, but I'll get this out of your way so you can still see what we're doing. We want to graph the original, graph the blue, and graph the red. Right? Graph the original and the dilated shape. No.
I just did not get that noise.
Yeah, neither did I, but it's middle school, so I just don't ask questions.
That's probably good.
I'm going to color code mine. Yo. What? Yes, I hear my name. This? No, this is class. Yeah, this is not on your worksheet. We're on graph paper. That's why I showed the 5-star. Like, so here's my negative 6, positive 8. Right? Here's my first point. I hope you guys are ahead of me, but there's my negative 6, 8. You don't have to label it, but that's, I believe that should be what it is if I counted right. Really small.
Do you see?
I thought I scaled it, but I just like did it by one, but didn't label everything. So it looked like I scaled it.
Ah, you scaled up by 2s, didn't you? Did you graph the original one too, or is that just the scale one? How's that the scaled one if it only goes up to 8? That's weird. What happened? I don't think you got it wrong, but I just don't know what happened.
It's right here, guys.
I know. I'm the only one that noticed that? Really? No, we
The
know that.
boys are like, wait, what's wrong? And the girl's like, he's acting. It's funny what you guys realize. Oh, by the way, this is updated. Sorry, Pete's. I feel a tiny bit bad, a teensy bit, because I didn't like have it up on the board when you guys walked in yesterday, like, you know, banging cymbals and saying turn in your homework. But then I did track some of you down this morning, and those of you that I tracked down were like, yeah, I didn't turn it in because it's not done. I was like, oh, well, then, you know, it's...
You also didn't give us a due date last week.
Yeah, I did.
Yeah.
I can go back to the video evidence and show you I told you it's due on Monday. That's also why I like filming my classes. Haha.
You never know when you might be approved.
I learned a long time ago that there's no arguing with middle schoolers. There's just what's right and wrong. So our original shape, right, what I drew in blue looks like this. But then when we start to graph the dilated shape, positive 12, negative 16, guys, this point, if you're at all confused, watch with me. This point becomes positive 12, wait, way out here, negative 16. So this actually ends up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I should have put numbers on here so I can stop counting all the time. Holy cannoli, it comes way down here? This is why I had to move my camera. I'm like, what the? It's way down here. So positive 12, negative 16. So when I walk around, I should see both of your triangles, the original and the dilated one. And then I want you guys to be able to tell me what happened and why. So what happened? I get it got bigger, but what else happened? What bit of both? No, that's very Maggie answer. That sounds like a custom. Ooh, I don't know if we put those in the right place. Because the first red, the top point, goes to positive 12, negative 16. We get positive 12, negative 16. So it's okay. You don't even have to erase that. You can write like on the side like you can pick a different color to try it again. This looks goofed up. You're working at 10, which is dangerous. All right, let's do this together. Because I'm telling a few of you that things look goofed up, and you're just getting upset with me. So, because I mean, nobody likes getting told they goofed. All right, hold on. A point at a time. Okay, stick with me. Hey, and if you're already done with this and confident, zip it. Love you, but zip it. You've got your homework. You can go ahead and work on. But some of us are confused, so I need to help those. My original x, y, and guys, we wrote this on our homework a little bit, is going to turn into, how could I write this? Not just negative x. Not just negative x and negative y. Negative 2x and negative 2y. So, negative 6, 8 becomes positive 12. Takes us out here to the right to positive 12. Negative 16 takes us down here to negative 16. Any questions on why my original xy of negative 6, 8 became 12, negative 16? Jordan. Okay. Wait, just flip? I don't know what you mean by just flip it. Like, just flip it like this? Or just flip it like this? Oh, you can't see what I'm doing. So be careful when you say just. I used to get yelled at by my coworkers. Like, no joke. Because I would say, oh, you just have to, like, talking about something on the computer. And guys, if it's easy for you, doesn't mean it's easy for them. That's why I outlawed easy. Like, that's why I said it's a bad word. Because I realized saying, oh, that's easy is really insulting. Like, it's really insulting. So, positive 6, negative 4 becomes negative 12, positive 8. Right? So negative 1, 2, 3, 4, 5. There's 5. 1, 2, 3, 4, 5. There's 10. So negative 12, positive 8. Oh, it's on line with that other point. So this one became negative 12, positive 8. So then negative 2, negative 4 becomes positive 1, 2, 3, 4.
Positive 4, 8. How convenient. There's 3 points on the same line. Mr. Hudson.
Yes.
So I was doing 647 and I abbreviated points of intersection to a line. Wait! Which also happens to be the first 3 letters of my question.
Ha. It's okay if you missed it. It was just noticing something interesting. So wait, somebody said you just flip it, but I don't think I can just flip it like this, because then this point would stay pointed up. And I don't think I can just flip it like this, because then this point would stay on the left-hand side but be pointed down. I'm like, anyone want to raise your hand and tell me what you actually think happened? Lily?
You reflect horizontally, vertically, then translate it and expand it.
Wait, we reflect it horizontally, vertically.
And then translate and expand it.
Oh, so then dilate it. Because translate means slide the thing, not change the size. So translate would be slide the whole. So hold up. Let's try this. Hold on. Sharpie. I know. So Lily says, flip it this way, flip it this way, and then expand it, dilate it. So she said reflect the Y, reflect the X, and then K. I got some people raising their hand and saying like, no, wait, but try this. Okay, so I think what Lily said works, because if I flip, and expand, it seems like it's pointed the right direction, right? That like the shape comes out the same. Okay. Anyone want to give me I got some people that were telling me do something different. So I am not sponsored by apartments.com, but sometimes it is convenient to have a upside and a downside of your Post-it. What Lily told me to do when I flipped, I ended up with my upside up again, right? So anyone got any other ideas? Spencer and Jordan, you both had your hands up. Jordan, you're the one who's saying like, wait, no, try this. What do you mean rotate? So rotate, that'd be 90. That'd be 180. So wait, rotate and then dilate? So wait, guys, wait, is it flip, or is it rotate?
It can be both.
Could it be both?
Yes.
Or could it be either, right? Like, could it be either option? Not that we're gonna do both, because if we flip, and then rotate, I think we get back to where we started. What, Brenda? And/or. Who's and/or? And/or. Oh, and/or. Oh. I thought we had some new student I didn't know about. So, I want your team to turn this into a mathematical conjecture. And, wow, what is that? Maybe he's going to define it if you, take a breath and listen. A mathematical conjecture, actually, it doesn't have to be straight for math. It can be for, anything you want to talk about. A conjecture is an educated guess based on at least 2 examples. So, what we have to have like a if we do this thing, then this thing happens, right? Most conjectures are written in if-then format. So if we do this thing, then this thing. Wow. Is anyone else really surprised that we're like almost out of time? Like 5. We only have 5 minutes. Like I can't. I'm genuinely surprised. Like yeah, but that I don't look at that. Who looks at that? So now wait, what? So if we're gonna write a conjecture, we need some like counter examples or other examples. What if I only did this negative multiplication to like one of my coordinates? So I want you to try this. What if, and I'm gonna change colors again to like green probably. What if now, instead of going to negative 2x and negative 2y, if we're going to try to conjecture this, what if I take my xy, what do you want to make opposite, the x or the y? Yeah, let's do x, because most of my x's should probably kind of be the opposite of what they are. It was a relationship joke. Most of my exes. I only have like 3 exes, honestly. You don't need to date that many people when you find the right one. So, negative 6, 8 would turn into positive 6, 8. Ooh, I can use that 4, 8 as a reference. So, positive 6, 8. Right, so positive 6, 8. I'm going to take my original. I know, I got some people who didn't listen and now they're confused. I'm going to take my original, and now, instead of what we just did, we're going to do negative x but leave the y alone. Do the opposite of the x, leave the y alone. Negative 2, so positive 2, 4, or positive 2, negative 4, and then negative 6, negative 4. I should have chosen a different color. What did, well, yeah, right in here there's a pentagon. What did multiplying by negative x do for us? My hand flies away sometimes. Who wants to tell, like, who? Okay, Jordan, what do we think did here? Wait. I did something to the x, and it reflected across the y? It's black magic, or I can't even, it's matha-magic? Black market? No, wait, what? So, if I... So this reflects across... Hey, hint, hint, cough, cough. This is going to be on a mastery very soon. Making the opposite of the x reflects across the y-axis. Guys, there's always a mastery very soon. So, let's make another conjecture then. How do we think we could reflect across the x-axis? Anna? So if we did negative y, it would reflect across the x-axis. Wait, didn't we say this guy rotated? So wait, if I reflect across the Y and I reflect across the X, does that just make my shape rotate? And this is where we're going to pick up tomorrow. Have a wonderful day. If you are green button mastered and you want next homeworks, I have them. But people are choosing to do math instead of getting mastered for other classes, and that ain't cool. So you got to show me green button mastered to get next homeworks if you want. What up?
I'm sorry, Mrs. Goldring.
I did it a lot of it. The first pair of rabbits, they'll still lie. And all rabbits, all pairs of rabbits, they'll be 14
I don't know, man.
Well, there's a lot of rabbits.
There are a lot of rabbits.
That was so nice.
Do what?
I feel so happy that color code that it looks so nice.
Right? It starts to look really cool as you play with geometry. I don't care. We're going to go over it tomorrow, but I'll give it back to you tomorrow.
Alright, I don't want to lose it, so.
I don't want you to lose it either.